Hey, hello everyone. I'm Dr. Santosh Chajad, M.Pharm PhD Pharmaceutical Sciences. In this video, I'm going to describe synthesis of aspirin. Structure is there in front of you. Aspirin can be obtained by acetylation of phenolic OH of salicylic acid, and reaction is there in front of you. You could see that salicylic acid, when undergo acetylation by using acetic anhydride in the presence of a sulfuric acid as a catalyst, formation of acetyl salicylic acid occurs. So now we will try to see the mechanism of this reaction. So beginning from the acetic anhydride, when it comes in contact with H plus ion liberated by sulfuric acid, so hydrogen is deficient in the electron, so it is acidic, and lone pair of electron present on the oxygen of an acetic anhydride will become coordinated with hydrogen of an sulfuric acid to form a bond between O, that is oxygen of an acetic anhydride, and H of an sulfuric acid, and formation of a conjugate base, that is nucleophile, will take place. Here, for sake of simplicity, I have written here A and H, means it's an acid. A minus is liberated is conjugate base, that is nucleophile. Species which is formed having oxygen is deficient in the electron when it comes in contact with salicylic acid. So lone pair of electron present on the phenolic oxygen will become coordinated with carbonyl carbon of an acetic anhydride. Carbonyl carbon is deficient in the electron, and that's why it accepts electron from the oxygen, that is lone pair of electron present on the oxygen. So that a new bond will form between oxygen and carbonyl carbon, and pi electron present on carbonyl double bond will become migrated on the oxygen because it is electronegative than carbon. So a conjugate base which is formed will coordinate its electron to the hydrogen, and a new bond will form between conjugate base A minus and H, and bonding pair of electron which was there earlier between oxygen and hydrogen will become retained on the oxygen, so that it will become stable now. So this is how oxygen has become stable now. So in the next step of the mechanism, oxygen, which is a part of acetic anhydride, will coordinate its electron to the hydrogen of an acid, so that a bond between acid and hydrogen will broken down, and bonding pair of electron will become retained on A. So conjugate base A minus will again generated, and a new bond between the oxygen of an intermediate which is formed and hydrogen of an acid will form. Here again you could see that oxygen has become unstable, it has got positive charge. In order to stabilize, oxygen will break that bond with the carbon and acetic acid will be generated, and you could see that OH present here over here. Now oxygen will coordinate its electron to the carbon, so that double bond will appear, and you could see easily that acetyl part will become introduced on the phenolic O. This is how final product aspirin become synthesized. As far as the procedure is concerned, into a 125 ml capacity earthenware flask, pour about 1.38 gram of salicylic acid, then add about 2.5 ml of acetic anhydride into the same flask. Then add few drops, that is 2 to 3 drops of concentrated sulfuric acid carefully, and swirl the contents of the flask till salicylic acid becomes solubilized. Heat the contents of the flask on a boiling water bath for 15 minutes, then allow to cool the flask in ice bath to form crystals of crude acetyl salicylic acid, that is aspirin. Then add about 20 ml of distilled water into the flask to affect the crystallization of aspirin. Filter the crude product at pump using Buckner funnel, and wash this product by using small portions of cold water so that inorganic impurity will become washed out. Crude product may be contaminated with unreacted salicylic acid, which can be removed by using aqueous sodium bicarbonate solution, because acid are soluble in sodium bicarbonate, whereas acetyl salicylic acid it is not. So into 50 ml capacity beaker, pour the crude product which is suspect to contain the unreacted salicylic acid. Then add 15 ml of 5% aqueous sodium bicarbonate solution, and effervescence will be observed if unreacted salicylic acid is present. These effervescence are because of liberation of carbon dioxide when carboxylic acid and sodium bicarbonate reacts. Filter the solution through Buckner funnel, wash the product with small portion of cold water again to remove the inorganic impurities, and allow to dry the product into the air. Recrystallize the compound from hot ethyl acetate. After complete drying, record practical yield and melting point of the purified aspirin. Now precautions while handling the chemicals, we are going to use salicylic acid and acetic anhydride. So it is there in front of you. What are the hazards are there associated with acetic anhydride? It is harmful if swallowed and inhaled. At the same time, it is flammable. So precaution one has to take while handling acetic anhydride is to keep away acetic anhydride from the burner and the spark. Wear the gloves while handling and handle the acetic anhydride in fume cupboard. Possible hazards with salicylic acid is it is harmful if swallowed and inhaled. It causes the serious eye damage. So in order to prevent these hazards, wear the gloves while handling the salicylic acid and wash the hand thoroughly after handling it. As far as the theoretical yield is concerned, we know that salicylic acid gets converted to acetyl salicylic acid. So we'll find the molecular mass from the formula. So molecular mass of salicylic acid is 138, molecular mass of acetyl salicylic acid is 180. So 138 gram of salicylic acid gives 180 gram of acetyl salicylic acid. So therefore, when we take 1.3 gram of salicylic acid, how much gram of acetyl salicylic acid will form? So percentage yield is equal to theoretical yield divided by practical yield. So X is equal to 180 into 1.38 divided by 138. So this is how we can calculate the theoretical yield. Now once you perform the synthesis of a compound, you dry it, you have to record the weight, you have to record the melting point, you have to perform the physical characterization by using TLC, you have to perform chemical characterization to check presence of unreacted salicylic acid by performing aqueous FeCl3 test. If violet color appear, gives idea that unreacted salicylic acid is there. Then you can perform spectroscopic analysis, you can record infrared spectrum and you can correlate the presence of corresponding functional group. So basically absence of phenolic OH group is expected in the IR spectrum of aspirin. So that gives the difference between the aspirin and the salicylic acid. So this is how you can record the results of your synthesis compound. Thank you. If you want to learn medicinal chemistry in simplified manner, do subscribe my channel and stay tuned. Thank you.